This is the study guide for the Unit 3 test on inequalities and literal equations. The first section deals with inequalities. The instructions, make sure you always read the instructions. It says to answer the following questions for each section, show or work. For number one, it says to solve and graph, so we do need to graph in this situation. Solving equations, the exact same thing as solving an inequality. When you solve either of these, step one is to get into what's called two-step form. Two-step form is number one, clean up each side. By that, I mean do the distributive property, combine my like terms. If you look at A, here I'd have to do the distributive property. If you look at example like B, here again I'm going to have to do the distributive property. Then I'm going to have to combine some like terms. On C, I can distribute or get rid of the fraction. And D, I'd have to again distribute, combine my like terms. So that's step one, is clean up each side. After you do step one, which is clean up each side, the next step, number two, is to, you can only have variables, so only variables or really unknowns on one side of the, we normally say equal sign, we can say the inequality symbol to solve. So if we look at any one of these questions, let's start with A. I have to clean up each side. The right-hand side is all cleaned up. The left-hand side I have to distribute. Whoosh, whoosh. Negative 4 times W is negative 4W. Negative 4 times 8 is a positive 32. Step one, which is clean up each side, is now done. Now I deal with the fact that there's variables on both sides. I have variables on both sides. Try to get rid of one of the two. I'm going to get rid of the negative 2W, the 2W by subtracting 2W, just to teach you something else. Negative 4W and negative 2W, negative keep change change is negative 6W plus 32 is less than negative 50. Now it's in two-step form, minus 32, minus 32. Negative 6W is less than negative 82. Divide by negative 6, divide by negative 6. We get W on this side is 12. 12. And since I divided by a negative, this symbol needs to flip. W is greater than 12. So plus, if that was correct, it's not 12. 6 goes into 82, 13 2/3 times. So that's 13.6 repeating, which is not really a good question. So let's graph this guy. We can do this a whole bunch of ways. The fractions aren't great. This is 13 and 2/3. I'm going to make this 14. I'm going to make this 13 and 1/3. Not really a great example of it. Either way, open circle. W is on the big side. If you look at an inequality, every symbol has a big side and a small side. There's the big side, there's the small side. W is on the big side, that's on the small side. So we're graphing W to the big side. Big numbers are always to the right. That's A. 1A. 1B, again, we got to clean up each side. This left-hand side, nothing to do. That's 15 minus 6n is greater than or equal to. This side we have to distribute. Keep in mind, I'm not distributing a 3. I'm actually distributing a negative 3. You might say, Mr. Mitchell, that's a subtraction sign. Keep, change, change. Now you obviously see it's a negative sign. So it's distribute, whoosh, whoosh. 9, negative 3 times n is negative 3n, and a negative 3 times a negative. That's not a negative 5, it's a subtraction. Again, keep, change, change. Negative 3 times negative 5 is a positive 15. Still not done because I have more cleaning up to do. Again, the left-hand side is fine, but on the right-hand side we have 9 and 15, negative 3n plus 24. We have variables on both sides. So what I'm going to do is I'm going to get rid of the negative 6n. I'm going to add 6n and add 6n. This is now 15 is greater than or equal to 3n plus 24. Now it's a normal two-step. So if I did with this, I had variables on both sides, got rid of that. Now I can solve normally. Minus 24, minus 24. Negative 9 is greater than or equal to 3n. Let me rewrite it over here. Negative 9 is greater than or equal to 3n. Division property of equality, that's the multiplicative inverse. Now, on this side is negative 3, does the symbol flip? The answer is no. It does not flip because I divided by a positive. It only flips if I divide by a positive. Sorry, if I divide by a negative. This negative was already here. This symbol stays like that. A lot of you guys get confused when you graph this. Some of you were taught to just look at the symbol and then go, oh, it's the way the arrow points. No, it is not. Do not graph it that way. You're graphing what the variable is. Again, if you look at the variable, it is on the small side. Every symbol, an equal symbol, has an equal sized opening on either side. But this symbol has a big opening and it has a small opening to get to the middle. And it's on the small side, so we do a closed circle, more ink, and we go in the smaller direction, and it's on the small side. So you cannot just do the arrow thing. This is your answer, and that is your answer for 1B. For 1C, we start to get a look at these fractions again. We can certainly deal with fractions. One of the things you are also allowed to do is if you don't like fractions, and it is all attached by multiplication, it is an interesting step. Since this is all held together by multiplication, I know you think there's an addition, but it's this quantity times that. You can multiply by the reciprocal, 4 over negative 3. That'll cancel, multiply this side, 4 over negative 3. We still have to deal with fractions, though, so I'm not even going to do that for right now. I'm just going to distribute the negative 3/4 out. Negative 3/4 times 2k. Again, you guys have really messed up with fractions. Fractions are not that hard, times 2k. Negative 3/4 times 2k. We're doing one of them at a time. 2k is 2k over 1. This is negative 6k all over 4. Negative 6k all over 4. Negative 3/4 times 5. Negative 3/4 times 5, which is really 5 over 1. 3 times 5 is negative 15. 4 times 1 is 4. So it's minus 15 all over 4 is less than or equal to 5. I'm going to erase these fractions. If you need to go back and pause it to look at them, you can go ahead and do that. Now we can deal with fractions, or you could do a little trick. If you want to multiply by the common denominator of all the fractions, in this case 4, 4, and 1, and you multiply every term by 4, here's what happens when you multiply every term by 4. It's not everything. It's not this times 4, the k times 4. It's every term. 6 and k, negative 6 and k are already part of the same term. So this is a term, this is a term, and that terms are separated by plus signs, minus signs, and inequality or equation symbols, equal signs. So we multiply this. Well, 4 in the numerator and 4 in the denominator just leave us with negative 6k. 4 in the numerator and 4 in the denominator leaves us with just minus 15. And 4 times 5 is 20. So now it's a much simpler one. You multiply by the 4. If this were a 3 and this were a 4, you would multiply this by 4 and this by 3. You have to multiply all of them by the same term. It just makes everything equal. You are allowed to do this because it's essentially distributing a 4 to the left side and distributing a 4 to the right side. Plus 15, plus 15. Negative 6k is less than or equal to 35. Divide by negative 6, divide by negative 6k. This is negative 5 and 5/6. And since I divided by a negative, this symbol again flips. It's fractions, which is not nice. When I have fractions, I tend to like to go by fractions, negative 5 and 5/6. That means this is negative 5 and 4/6. That means this is negative 5 and 6/6. Well, 6/6 is 1, which is negative 6. It is a closed circle. More ink is more ink. Since k is on the big side, big part of the inequality, small side, we're graphing k. We graph in a big direction. You could also shade this way, or you can go up and over. The big numbers are always to the right. Even the negatives, the bigger numbers are this way. 1D, again, we got to follow our rules. Clean up each side. On the right-hand side, nothing to clean up, but on the left-hand side, plenty to do. I got to distribute first. Why do I distribute before I add 80 and negative 10? Well, we still follow order of operations. In terms of order of operations, multiplication comes before addition. So we still have to follow order of operations. If you combine this 80 and 10, you're not doing it correctly. You have to follow order of operations. 80 plus 4 times p is 4p. 4 times negative 10 is negative 40. That's not a negative yet, it is. Well, 4 times keep change, it's a negative 10. 4p minus 40. Now I combine my like terms, so I'm still not done with step 1. 80 and a negative 40 is 4p plus 40, because a negative 40 and 80 is just 40 left over. At this stage, we're done with cleaning up. We look at the next one. Only unknowns on one side of the inequality symbol. Well, I have unknowns on both sides. So I'm going to take away the 4p and do the same thing, subtraction property of equality. This side we have 40 is less than negative 10. Now all my variables cancel, which is possible. If this situation arises, look to see if it's true or not. Is 40 less than negative 10? The answer is no, it's not. Since it is not true, this is a no solution scenario. You can't graph it. The answer is not this. On the answer line, do not write that. You need to write the words no solution in order to get correct. There's no number that you could plug in, no solution that would make this inequality true. This side will always be bigger than that side, and that's not okay because of this symbol. 1e, again, plenty of cleaning up to do on this side. The left side is all good to go. The right side, let's see, negative 6 times 2b is negative 12b. Negative 6 times a negative 10. That's not a negative 10. Yes, it is. Keep, change. It's a negative 10. Negative 6 times negative 10 is a positive 60. And then the plus 5b. Again, if you tried to combine the 5b and the 2b right from the start, you should not have done that. Multiplication comes before addition. I thought we'd do reverse when we're solving. Yeah, you do reverse when we're solving, but we're not ready to solve until we do 1 and number 2. This is normal order of operations. This is normal order of operations. And once we've done both of these, then we go backwards with SAD method. Left-hand side, still nothing to do. Right-hand side, combine my like terms. Negative 7b plus 60. Variables on both sides. I'm going to add 7b and add 7b. It really doesn't matter. I chose to do this way. 3b plus 84 is greater than or equal to 60. Now I've done both of these things. I can start solving. Now I do reverse. Minus 84, minus 84. 3b is greater than or equal to negative 24. Division property of equality. I have b. On this side is negative 8. Does this symbol flip? The answer is no. I divided by a positive, so it stays the same way. If I were to graph this, negative 8 is in the middle. Closed circle, more ink means more ink. B is on the big side, so I go with the big direction, which is always to the right. And last question, number 1. Clean up each side. Well, 8w minus 6w, that's 2w, so I had some cleaning up to do over there. 24, some cleaning up to do over here. 24, negative 9 and negative 1 is negative 10w. Some of you may have messed that up because you thought it was just 9w, you made that 8w. Well, a negative, that's not a negative. Again, keep, change. A negative 9 and a keep, change. A negative 1 is a negative 10w. Variables on both sides. I'm going to do this one just to show you guys, because this is one way that you, again, get messed up. So negative 2, subtract 2w, subtract 2w, because I have, well, first of all, I've cleaned up each side. Now I have variables on both, so I'm going to get rid of the negative, the 2w. This is 0 is less than or equal to 24 minus 12w. Again, that's negative 12. Keep, change is a negative 12w. Sometimes students panic when they see a 0 on one side. Don't panic. That's just a number. 0 is a number. Let's continue solving because now I've done 1 and 2. Unknowns on just one side. Minus 24, minus 24. Negative 24 is less than or equal to negative 12w. Don't forget that's a negative 12. So if you write down positive, it is a negative 12w. It does not flip because I'm subtracting. Again, it only flips when you multiply or divide by a negative. Speaking of which, we're about to divide by a negative. I have w. Negative 24 divided by negative 12 is a positive 2. And this symbol will now flip because I divided by a negative. W is on the small side of 2. To graph this, we have 2. Make sure your number line is done correctly. Closed circle, once again, because there's more ink. W is on the small side, which is to the left. Small is always to the left. Again, on this symbol, this is small, that's big. W is on the small side. To the left. Question 2 is interesting. It says to solve, then list which of these are a solution. Now, of course, what you could do is you could plug in -3 into all of these spots and see if that works. Then plug in -6 and plug in 0. You could do all of that. If you're at a loss for what to do, you can plug in each one of those and see if it's true or not. Or you could just solve it, and it's a multi-step equation. You can just solve it and then figure out which one, where the solutions actually lie. Now let's take a look. See these parentheses? We distribute what's on the outside, but it's just a 1. It's plus 1. So there's actually nothing to do there. It's kind of just messing with you. This one, though, we do have to distribute. A lot of students will distribute the number 3. That would be incorrect. You're not distributing 3, you're distributing a -3. And that's a subtraction sign. Again, keep, change. It's a -3 being distributed. -3 times h is a -3h. -3 times 6 is a -18 is less than 24. Still have to clean up this side. I got a 2h, a -7h, and a -3h. 2 and -7 is -5. -5 and -3 is -8h. A 2 and a -18 is a -16 is less than 24. Now we're in two-step one. We can keep solving. Add 16, add 16. -8h is less than 40. Divide by -8, divide by -8. H, -5, and yes, that symbol flips. We're looking for any numbers that are bigger than -5. Is -3 bigger than -5? Yes, it is. Is -6 bigger than -5? No, it's not. It's further to the left. Is 0 bigger than -5? Yes, it is. Is -5 bigger than -5? We'll come back to that guy. Is -8 bigger than -5? No, it is not. So the question is this one okay? The answer is no. -5 is not bigger than -5. We're looking for things that are bigger than -5. If there were a line underneath, would this be an answer? Yes, it would. But since there's no line underneath, it's not equal to, the answer is just C and A. Bit of a word problem. Almost easier than it looks. It says Morgan works at the Hippo Pen at Gralston Zoo and is in charge of feeding the alpha hippo bread. Since bread is on a special diet, half of his calories at breakfast are no more than 4,000. So half of his calories, so 1/2, we'll call B, we'll call it his breakfast calories, we'll call that B. 1/2 of his breakfast calories can be no more than, which is less than or equal to 4,000. So half of the calories he gets is not more than 4,000. So half of that, whatever that is, or you could do B divided by 2, is not more than. So not more than would be equal to is not more than, and also less than is not more than. So either one of these would be acceptable. If Morgan fed him 5,200 calories, how many more can he consume? In order to sort of look at this, we kind of have to solve this guy. We'll solve this one. B divided by 2 is less than or equal to 4,000. Well, if we solve this, that's times 2 times 2. B, 8,000, this symbol does not flip. So at breakfast, has to have less than or equal to 8,000. We already had 5,200. 8,000 minus 5,200 is 2,800 calories. Is how much more he could have. So for this one, it's B divided by 2 is less than or equal to 4,000, which we know if we solve it, it's 8,000 calories. We already had 5,200, that only leaves 2,800 calories for Brett to consume. Part 2 of this has to do with solving for variables. Answer the question for each section, show all work to receive full credit. Again, show all work. Number 1, put the linear equation below into function form, which is solve for y. I'll give you some tips as we're solving these. Number 1, it says to solve for y. The first step in solving for y, solving for a variable, is to isolate the term that contains your variable. In A, there are 3 terms. Terms are plus signs, minus signs, and equal signs. This is the term that contains my variable. So lucky for me, it's already been isolated, which means to get it by itself. Since it's already been isolated, I move on to step 2. which is now isolate the variable. And that's usually by just multiplication or division. In this case, divide by 5. Every term gets divided by 5. Just like that equation up earlier, when we multiplied by 4, every term got multiplied by 4. Every variable gets divided in this case. Y equals 15 over 5 is 3x plus 10 divided by 5 is 2. Y equals 3x plus 2. I can write it as y equals 3x plus 2. That's called the symmetric property of equality. B. Again, let's isolate the variable that can, isolate the term that contains my variable. There's 1, 2, 3 terms. Here's the term that contains my variable. Let's get rid of the rest of the stuff. Add to the inverse, add 3x, add 3x. 4y equals, here's another tip. Send the constant to the end. Send the constant to the end, send the constant to the end, send the constant to the end. I could definitely write this as 24 plus 3x, but this is my constant, send it to the end. It may not make sense now, but trust me, it'll make sense in the next unit. Send the constant to the end. So instead of doing 24 plus 3x, which is, by the way, not 27x, let's make this 3x plus 24. Make sure you maintain the signs. When I divide, do part 2, which is isolate the variable, every term gets divided by 4. Y equals 3/4 x plus 6. Yes, you can make this 3x over 4, but 3 over 4 is just 3/4, and the x can just drop to the side. So y equals 3x. 3/4 x plus 6. C. If you follow my rules, which is isolate the term that contains your variable, you might be tempted to get this by itself. But really, right now, these are not separate. These terms are not separated because, unfortunately, this division bar is kind of holding them together. It's like two toy soldiers that are glued together with one wood plank. It's sort of like one toy. In order to separate them and make them two separate toys, I have to get rid of the wood plank. How do I get rid of the wood plank here? Well, I have to get rid of the fraction, which is times 12 times 12. 3x minus 6y equals 12 times 2 is 24. Now there are two separate toys, two separate soldiers, that I can isolate the term that contains my variable. Goodbye to the 3x, goodbye to the 3x. Don't forget it's a negative 6y. A lot of students forget that. And then again, I could make this 24 minus 3x, but send the constant to the end, send the constant to the end, send the constant to the end. Negative 3x, don't forget the signs, a negative 3x. No, it's not subtraction. Again, keep, change, change. It's a negative 3x, and it's a positive 24. 24 is positive, the 3x is negative. Divide every term by negative 6. Y equals negative over negative is a positive, and it's 3, 6x minus 4, but 3, 6 simplifies to 1/2. 1/2 x minus 4 is your equation in function form. These are asking us to solve again, but this time it says for the given variable, not for y. This one says to solve for t. Step 1, isolate the term that contains your variable. Again, there are 1, 2, 3 terms. The last one is the term that contains my t, at. So minus r, v minus r equals at. Since it's not a number, I can divide by a, and I can divide each of these by a, or I can just make the whole thing over a since it's not a number. V minus r over all over a. I would also probably accept v over a minus r over a. They're both equivalent. They're both the same thing. B, solve for x. This is very similar to the one I talked about above with the toy soldiers. Again, if you follow my tips, isolate the term that contains your variable, you might say these are separate terms. They are not yet separate terms because they're held together by one piece of wood that's gluing them together. I got to get rid of this wood, got to get rid of that glue. So how do I get rid of that? Well, again, I'm going to multiply by 2. That'll get rid of that. I have 5xy plus n equals negative 2 times 6, sorry, negative 6 times 2, which is negative 12. Now I have two separated terms. This is the term that contains my variable, minus n. 5xy equals, send the constant to the n, negative n minus 12. This looks confusing, but it's really not so bad. I have the x, which I'm trying to solve for, and I have 5 and y on either side of it. So since it's all multiplication, let me just divide by 5y. That cancels that out, that cancels that out. I have just x left over. I'll divide the whole thing by 5y, similar to what I did over here, since it's all kind of variables and kind of nasty anyway. Negative n minus 12 all over 5y. If you were to have written x equals negative n over 5y minus 12 over 5y, I personally likely would have accepted that as an answer. C says to solve for a, but there are two terms that contain my a. So let me just put them back together on one side. Divide 3a, divide 3a. 4a minus 3a is just 1a, or a. A plus b equals, well, there's nothing over there. Again, variables on both sides, we've done this before. Please don't make it 7 because they're on opposite sides. Minus b, a equals 0 minus b, which is, you could say it's negative b plus 0, but that's the additive identity. Adding 0 stay the same, so it's just a equals negative b. 3c, it says to solve for c. Again, three terms, f, 5/9 c, and 32. This is one that you certainly should pay attention to. Solving for c, first we isolate this term that contains my variable, divide 32, divide 32. F minus 32 equals 9/5 c. When we have fractions, you certainly could divide by a fraction, but that's really confusing. So we do not want you to multiply by a fraction. We do not want you to multiply by a fraction. I want you to divide by a fraction. Do not divide by a fraction. What you should do is multiply by the reciprocal. There's something you need to know how to do. You need to multiply by the reciprocal. A lot of students will multiply by the reciprocal. The reason we multiply by the reciprocal is 9 cancels 5 cancels, we have c. Students always know when you multiply by 5/9 on this side, you multiply by 5/9 on this side. So what students often write is 5/9 f minus 32, and that is incorrect. It is wrong because what I have written is only multiplying the f times 5/9. It's not just the f, it's both terms, the entire quantity, the entire thing in parentheses. So your final answer needs to look like this with parentheses. If you don't have these parentheses, it is incorrect. C equals 5/9 times the quantity f minus 32 is the correct answer. Again, I would certainly pay attention to that one. 3e says to solve for c. Again, it looks kind of confusing because now c's in the denominator. You might say, well, I have no idea what to do. If you do nothing, that's not the best way to handle it. You should at least do something. We've already dealt with situations where it's kind of like, again, these two toy soldiers glued together with one wood plank. We've got to separate these terms by multiplying by c. So maybe I don't know what to do, but I can at least try that. So I've divided by c, and that cancels 3x plus y equals 4c. Well, at least c is no longer in the denominator of the fraction. It's now as a numerator. But now if you look, I've actually done step 1. Isolate the term that contains my variable. Now c is by itself on the right side. This is one term. Yeah, it's being held together with a 4, but I've isolated that term. Now it says to isolate the variable. So we divide this by by 4. Let me divide this side by 4. And I have c equals 3x plus y all over 4. So it really just looks like the 4 and the c swap places, and that's my final literal equation rewritten for a different variable. Now I'll do number 4, which is still isolating the term that contains my variable, but there wasn't any more questions with 3. Now it's just like symbols. You do need to know how to do this. Maybe we'll see one like this in your test. But just saying to solve for the heart. This is a square times a heart minus a circle equals a triangle. It's really no different than if it was like x times y minus k equals capital G. It's the same idea. It's just symbols. So in this situation, if we were asked to solve for y, we would add k, isolate the term, and then get rid of the x. That's what we're going to do here. Isolate the term, isolate the term that contains my heart. Plus a circle, square, heart equals triangle plus circle. Divide by square. We can divide each term by square if you want. And we would have heart equals triangle over square plus circle over square. We also would accept Part equals triangle plus circle, all divided by square. Either one of these would be acceptable answers. Moving on to the last question, which should look familiar. It says, Dr. Strangelove is a scientist studying climate and needs to convert some temperatures from Fahrenheit to Celsius. He knows the formula for converting temperature in degrees Celsius to degrees Fahrenheit is given by this equation. Solve the formula above for C to get a formula that can be used to convert Fahrenheit to Celsius. So again, it says solve for C. How are we going to solve for C? F equals 9/5 C plus 32. My rules are the same, which is isolate the term that contains my variable. There's 1, 2, 3 terms. This is the term that contains my C. Minus 32, minus 32. On this side, 9/5 C, and this is F minus 32. Again, you could divide by a fraction, but we are encouraging you, do not divide by a fraction, do not divide by a fraction, do not divide by a fraction. You should multiply by the reciprocal. When you multiply by the reciprocal, the tops and bottoms cancel. And if you do this, 5/9, you end up with C equals 5/9 F minus 32, which is, again, incorrect. Because when you multiply by 5/9, you need to multiply every term. Now, how do I multiply every term? That's where just the distributive property or the quantity comes in. You need to use parentheses. If you don't have parentheses, it would be considered wrong. This would be considered correct for rewriting this formula. Part B says to use the formula we just created to convert 84 degrees Fahrenheit to Celsius, round to the nearest tenth of a degree if necessary. Man, it would be a shame if students lost points because they did not pay attention and didn't round to the nearest tenth. I'm going to reset this so that I can rewrite my equation and do it down here. I remember my equation was, use the symmetric property. C equals 5/9 F minus 32. And let's plug in. If this is my Fahrenheit, so we plug that in for Fahrenheit, C equals 5/9 84 minus 32. Follow order of operations. 5/9 84 minus 32 is 52 times 5/9. So when I multiply that, I get 28.8. Now it says 8888889. Obviously it's 0.8 repeating. When it's doing this and then all of a sudden it's a 9, it's because the calculator rounded it. So it's 28.8 repeating. If I were to write that, that would be incorrect. It says to round to the nearest 10. Again, it'd be a shame. This is the tens place. So this 8 rounds that 8 up. It's 28.9 degrees Celsius if I want to get full credit.